Hi, welcome to another AQA A-level chemistry video. Today I'm going to be making a video on nature and preparation of amines. So I'll be going through the nature of amines, classification of amines, and how to prepare them. In your exam, you're going to need to understand how to classify these amines, name them, and as well as you need to understand the differences, the different ways of preparation, and the advantages and disadvantages of each method of preparation. Those are the things that are going to come up in your exam, and there's a few. That's pretty much all you need to really know for your exam. There are a couple of. I mean, there's only really one mechanism that you really need to know. There may be other ones, but really there's only one main one that you need to know, and that's just nucleophilic substitution that you should know already. So, apart from that, I'm going to go straight into video. So, nature of amines. Amines are organic compounds that contain nitrogen, and they can be thought of as alkylated forms of ammonia, for example NRH2, and you can have both aliphatic or aromatic amines. So amines are just, when you think about amines, they are literally just alkylated forms of ammonia, in the sense of the fact that if you think about ammonia here, right, if you think about this here is an example of a primary amine. I'll go through different types of amines like primary, secondary, tertiary, and so on later on in the video. But it is literally just an alkyl group that's bonded to the amine. So I have this here, oh, I don't like that, and I have this here, one H here, and instead of another H being bonded here, we have an R group, and that's an amine. It's just it's an NH2 group or nitrogen that's bonded to another hydrogen of some sort, or just in fact, you can have a situation where when I go through later in the video where I show you, we have more than one R group that's bonded to nitrogen, or all R groups bonded to nitrogen. That's an example of and these are examples of amines. They're just bonded to the nitrogen. And then there's two types of amines. There's aliphatic amines and there's aromatic amines. Aliphatic itself, it just means it could be either saturated or unsaturated, but it's usually like they're chains. They're non-aromatic, so they're just like so it could be a saturated or unsaturated side chain. I've got an example here below. But we just think about simple side chains. It could be long side chains. It can be as long as they want to be, but we'll think about non-aromatic. So kind of chains. Whereas aromatic are, when you hear the word aromatic just means ring. So they're rings of some sort. They can be as small as a ring of three, a cyclopropyl group, or it could be as a really big group, a really big ring, or it could be the one that we most commonly see, which is a benzene ring, and they have a particular naming of it as well. Yeah, so now I'm going to go straight into going into aliphatic amines into a bit more depth. So, right, so with aliphatic amines here, we have the aliphatic group, which could be, I mean, I could change it to being one of this here, if I wanted to here. It doesn't really matter, but it's just understanding that it could be saturated or unsaturated. It's just a side chain, simple side chains that are bonded to the nitrogen, to giving a type of amine. This particular example is a secondary amine. As I said, I will go through the differences between primary, secondary, and tertiary. But this is primary, secondary, and tertiary are very similar in terms of the way you'd think about alcohols, where I have primary, secondary, and tertiary alcohols. It's kind of like that sort of thing. But the most important part I need to know that I haven't really prepared in this video here, but I can actually do it really easy, and I'll do it throughout, is naming. You have to be able to name amines. And the way you do so is the same kind of way that you'd go about naming the rest. By UPAC, you kind of go look at, you look at the longest chain. So in this case, if I'm looking at this, I'll just, I'll put this here. Then you go to do not disturb. Great. What I'm looking at here is I'm looking at the longest chain. In this case, clearly the longest chain. So that's 1, 2, 3. If there's no longest chain, I'll go through an example where it has no longest chain. But if in this example here, this is the longest chain. So then that would be our suffix. Our prefix would be in the shortest chain. Now, how we represent this part here, which is an ethyl group, we go about saying N, because we always show from which part we'll talk about. So we say N to say from this part onwards, not this part onwards or from here onwards. It's from here onwards. N ethyl, because this is an ethyl group, 1, 2. And then this is the main part here, 1, 2, 3. And then we would just go about saying N-ethyl propylamine. This is a propyl group and it's the longest group and it's bonded to the amine, so it's N-ethyl propylamine. Now what if I change this? So what if I added what if I added this group here, right? Then we would have, if I added that group there, if we have two of the same group and it's not the same size, I could call it this, right? I could call it we now change it to doing so I'm just trying to work out, put this all here. It would be, now we have two of the same type of group and then you have the main group. We call this N diethyl propylamine. You see that? N, because you have two of them, diethyl propylamine. Okay, what if I do this now? Right? I haven't got the best way of explaining it by step. I'm just kind of going through examples to help you so you can see. I think by showing you examples of what I'm saying, if I try to explain it logically, it might confuse yourself. I think the best way that I do it is by showing you examples. So, well, how do I go about this one here? So I'll go through the shortest group first. Remember, we know the longest group here is the propyl group, right? So then we'll say, first of all, we say N-methyl and ethyl propylamine. And then that is what you need to know. I said before I was going to show you an example where we have two. So okay, so what if I had this? What if I had this situation here, right? Where I had what if I did this? That's now 1, 2, 3, 1, 2, 3. Yeah. So how do I go about doing this? I want you to try and do this. I want you to try and pause the video now and try and think about what the naming of this compound would be. Alright, so I've assumed pause the video and you try to answer it. So I would go about saying they're all the same compound. So I'll just say it's just tripropylamine. It really is just, I don't really have to say, I could say NNN trimethyl. I mean, but we all know it's coming from this central N here, but I would go and say NNN just in case. You wouldn't lose anything by saying NNN. I don't really believe it's necessary to say it because you already have, you already know it's coming from it, but NNN tripropylamine. And that's all it's saying here is that there's 3 propyl groups bonded to the same nitrogen, NNN tripropylamine. Hopefully the naming made sense. If it didn't make sense, leave a comment in the description. I can try and reword it. If I've made a mistake and you've seen me make a mistake, then also don't feel afraid to let me know in a comment. I can take that. Yeah, so aliphatic amines, as I said before, just amines containing aliphatic R groups, both saturated or unsaturated, such as alkyl chains. The alkyl chain may be as short as a methyl or much longer. The aromatic amines here, said before, so this is an example of a benzene group here. So aromatic amines share the same general formula as aliphatic amines sometimes, but aromatic amines have an aromatic R group. So they could have the same functional group as it, but it's a completely, so it's the same general formula, but the aromatic R group, if it contains an aromatic group, it's an aromatic amine, and that's what makes it different. I'd love to know how you guys would name this, but I mean, you may not know how to name them. I'll just go through the name. This when you ever see a benzene ring, or if it's just a simple amine, you can just say, if it's, for example, this, I mean, I'm not gonna go, okay, I'll go through this one here. Well, with benzenes, benzenes are always phenyl. Unless it's like it's got more than 6 carbons attached to it, it's usually phenyl. It can be benzene, but usually when you're talking about amines bonded to a benzene group, we call it phenylamine. Don't like that P. Phenylamine. This phenol part here is just talking about the benzene ring. But what if it's something like this, right? What if it's just a normal cyclohexaamine? Well, I've just said it. I've literally just gone through here. It's like, we just call this compound cyclohexaamine. I mean, do I have to write it down? But yeah, I mean, I'll write it down for you. Cyclohexaamine. Yeah, I would have to say 1 because you know it's always going to be from 1. Unless there's a side group here. You guys know how to do UPAC. Unless there's a side group here, you go say 1-methyl, for example, cyclohexaamine. Would be 1, no, it would be 2-methyl cyclohexaamine there. If I added one of these. So if I change this, right, if I change this to this, hopefully you're getting this. I really hope that I'm just hopefully you're getting this and I'm not just like kind of annoying people by doing this, but I'm just making sure that people get this. So it'd be 2-methyl cyclohexaamine. So I kind of had to go underneath there, but the point being here is that you understand how to do the UPACs of these and priorities. I'll go through primary, secondary, tertiary a bit later on in this video, but that's like kind of the basics. So amides. So there's another type of amine and amide. So amides are amides are different to amines, but we must also be able to identify them. They crop up throughout the course, so you need to be able to understand what they are. And amide contains an RCONH2 group, as shown above, so that's what makes them a bit different. We don't usually see in this carbonyl group that's bonded to it. But if you do A-level biology, you would see this all the time. You don't think about this part here, but this is what you see when you have when it's bonded to amino acids, when you're forming a polypeptide chain. The H2 part, no, you won't see that part. It'd be H, and then you're bonded to your carbon. But this RCONH2 part, RCON part really, NH part, that is what you'd see when you're having in a peptide bond. This is a peptide bond, right? This little part here. This is the main part of the bond that you need to understand. Sorry, slight technical problem there. Don't worry about that. I'll just be going through the rest of this. So, as I was saying before that little incident there, this is the most important part of the group. This CONH part here, that's the actual functional group there for an amide, and it can be given as this here, right? You can write it as CO, or you'll see it as this. The carbonyl group, this is the CO part, and H. If it's an amine in particular, it will go on to you can write it like that. But if it's so this is an amide. Just to make that clear, this is an amide. But if it can just be another H here. But usually, if you're talking about in when it's bonded to, or when it's acting as a massive bond, we're thinking about it's bonded to some other R group. So this is an amide, but this is also an amide if it's bonded to another R group. And that'll be bonded to some other R group as well. But this here, this little part here, that's the amide. That's the part that actually matters. And that's the main part of it. And yeah, so far I've covered what aromatic amines are and how they contain aromatic R groups, and the aliphatic amines and how they contain aliphatic R groups. Sorry, I said that wrong. Aromatic amines and they contain aromatic R groups, and aliphatic amines and how they contain aliphatic R groups. Now we're going to go through the classification of amines. So amines are both aliphatic and aromatic and can be classified into primary, secondary, and tertiary amines. So kind of like with alcohols, you have primary, secondary, and tertiary alcohols. It's the same kind of concept. So with alcohols, you're talking about the carbon. Well, I'll change it back to white again. You're talking about what how many carbons are bonded to the carbon that's bonded to the hydroxyl group. So if we're talking about a primary alcohol, we have one carbon or no carbons. A maximum of one carbon that's bonded to the carbon with the hydroxyl functional group. So methanol is a primary alcohol because it has one or no, in this case, has no carbon that's bonded to the carbon with the functional group. But also if I had ethanol, right? Ethanol would also be an example of a primary alcohol because it has only one carbon that's bonded to the carbon. One carbon that's bonded to the carbon with the hydroxyl functional group, and it's kind of the same thing with amines. We're talking about how many R groups are bonded to the nitrogen. So technically, if I'm being honest, right, the most basic primary amine is just ammonia. This is technically a primary amine. We didn't talk about it much, but it is technically a primary amine. But the ones that you because it has no R groups or one or no R groups bonded to the nitrogen. But primary amines contain one R group and two H groups. That's generally what we consider. So NRH2. So N, this is the R group here, and H2. All right. Now, actually, you know what? I want people to, as I go through it, I want you to try and name it. So I want you to pause the video now and try and name this compound here. And I want, after you've done that, after you've paused and tried to answer that, I want you to try and give the name of this compound here, and I want you to give the name of this compound here. At least try and do it. That compound there. Good. All right, so this name here would just be as simple as just saying 1, 2, 3, 4. That would just be butylamine. I don't have to go and say N something. We only do that when we have side groups. Secondary amines. So secondary amines, like I have with secondary alcohols, there's two R groups that's bonded to, or two carbons that's bonded to the carbon that's bonded to the hydroxyl group. So with amines, just that there's two R groups that's bonded to the nitrogen, right? And that's the compound. That's what you have to understand about that. So it's very simple understanding. How do I name this compound? Hopefully you've already done it already, but I'll look at the longest group here, 1, 2, 3, 4. And this is the shortest group here, so it'll be N-ethyl butylamine. N-ethyl butylamine. 1, 2, 3, yeah, good. Now, tertiary amines, same with tertiary alcohols. There's 3 carbons that's bonded to, when we're talking about tertiary alcohols, we're talking about 3 carbons that's bonded to the carbon that's bonded to the hydroxyl group. And it's the same concept here with nitrogen. I know this is probably annoying a lot of people, but it's really, I'm just trying to hammer it home what I'm trying to talk about here. And so, 3 groups are bonded to nitrogen. There's no H group. So tertiary amines contain 3 R groups and no H group, and are given the general formula NR3. So in this example here, I had hopefully this one may be a bit difficult for people to name, but I will go through it. So first of all, identify the longest chain. 1, 2, 3. It wouldn't be this group here. This is considered the chain group. So this is 1, 2 really. And this is 1, 2, 3. So that's the longest chain. So I'll go through and start saying N first for that group here. Ethyl. That's an ethyl group here. N. Ethyl. Now there's 2 ways that you can name this one. You can go through the ISO method, or you can just call it the proper UPAC name. So I'd call this isopropyl. In case I'm pretty sure it's called isopropyl. That's how you name it. But in case I'm wrong, forgive me. So N-ethyl, N-isopropyl, propanoate. Sorry, why did I say propanoate? Propylamine. Sorry, not propanoate. Propylamine. N-ethyl, N-isopropyl, propylamine, not propanoate. Sorry, never not. This is not a an ester. It's not anything like that. This is an amine. Don't say propanoate. That's kind of slipped out my mouth. Propylamine. So N-ethyl, N-isopropyl, propylamine. I'm pretty sure these are called it won't be 1, 2, 3. That's why they call it isopropyl. But you can name it by this way: N-ethyl, N-isopropyl, propylamine, or you can go through this part here: N-ethyl, N-methyl ethyl. I should probably make it a bit more easy to see with the gap here. Propylamine. So if you're answering this question, you say, how would I name this? So this is quite confusing. I don't even know where to start, right? Remember what we started. We say the longest group. So you know the suffix is the longest group here. It's going to be a propyl group. It's 3 here. So you know it's going to be a propylamine. All right, cool. What's the shortest group here that I can say? So we know that the other 2 groups are going to be part of the prefix. So the shortest one here is an ethyl group. So that's N-ethyl. So the one at the start, the N-ethyl and the propylamine part should be very easy for you to spot. The parts in the middle that may confuse you is this iso group here. I've just decided to add it just to make it a different type of name. But you can go through the iso group, you're calling it isopropyl, but that really makes you kind of scared because you don't know how to properly name it. You can then also call it methyl ethyl. They're both the same thing. They both give you the same mark in the exam. If you said iso or methyl ethyl, they both count. So that's it. That's gonna. But now I've gone through what a primary, a secondary, and tertiary amine is. So hopefully you understood that. However, amines are slightly different. There's actually a possibility for another group, which is a quaternary amines. There is a primary, secondary, and tertiary amine, but there's also a possibility for quaternary ammonium. So we won't call them quaternary amines. We call them something a little bit different. We call them ammonium ions, and under certain conditions, there's a possibility for a 4th group being added through a dative covalent bond, and this is possible because the lone pair of nitrogen, for example, a methylamine in acid, you can actually form a 4th bond. So you can this is possible just because there's a lone pair of nitrogen. So if you have a tertiary group, a tertiary amine, there's still that lone pair can then form a dative bond with another group. So for having an ammonium ion in particular, just an ammonium ion, it need to be dissolved in acid, obviously, because if it's not in solution, then you won't form the ion. It needs to be dissolved in a acid to actually form the ion. When it's outside of solution or outside of an acid, i.e. it's not dissolved in an acid, it will just be a salt, and it's usually whatever the salt that you have with. So if it's if you have it with bromine, you can have ammonium bromide. Alright, but this is one thing you need to get about. So these molecules are called ammonium ions and are often found as ammonium salts. And this is because the ion is much more stable in this form. So if this is dissolved in acid, we have here methylamine, or I mean this is just a methylamine, but the general names that are given to these are either called quaternary ammonium ions. This is the quaternary ammonium ion. If we change this now and we changed it to be so this is dissolved in acid. If it wasn't dissolved in acid and it was just free as a solid, we would call this, and we had CH3Br, like a methylbromine, for example, right? That's no longer a quaternary ammonium ion. We now have a quaternary ammonium salt. So this is, if they ever ask you how you would name this, if they ever ask you what this is, that's just a primary amine. In the exam, you can say, I mean, I don't like saying it like this. They usually allow this for some reason. That being signified as primary. This means primary. So that's primary amine. I don't like doing that just in case they say they want you to name it. Just say primary amine just to be certain. But they do allow that for primary amine, or this for secondary amine. I don't like that in particular. If you're doing shorthand and you need that short, if you're taking notes, that's a good way of doing it. But though in the exam they allow it, just say secondary amine. They also allow that, and just make sure that there's no confusion. They might take that away from the marking. You know what I mean? They can't take that away though. And this would be a tertiary amine, right? That's how I say. And then this, we don't call this a quaternary amine. It's no longer an amine now. It's now a quaternary ammonium ion or quaternary ammonium salt, depending on what example that they've given you there. But that's how you would name these ones here. So the preparation of amines now. So I've now talked about the classification of amines, but it's important to know actually how to prepare amines. And there's two main ways of preparing amines. So there's two main ways of forming amines, but there's advantages and disadvantages of either method. I'm going to go through them from now. So preparation of amines, so halogen alkanes and ammonia, right? So we can produce amines by heating halogen alkanes with excess ammonia. That's quite important here. Excess ammonia, that is a condition. And to below shows the nucleophilic substitution mechanism of how this happens and the overall reaction, what the overall reaction is. So if this is just a nucleophilic substitution of chloromethane with ammonia, and with excess ammonia, and that's literally what you know from AS chemistry, just normal substitution reaction, where you'd have the lone pair from the nitrogen on the amine going to the carbon that breaks the bond here for chlorine. That would then form this little intermediate here, where you have you'd have to break this bond here. Because ammonia prefers to have 3 bonds instead of 4. You have your little Cl minus nucleophile that's being ejected out, and then we have here a methyl amine. Yes, methyl, or we can call it methyl amine. I prefer calling it methylamine, but it doesn't really matter how you say it. But you don't have to write it down. But I just want to clear up one thing from this. Is that I see some people ask me this and they kind of get confused. The reason why I've always said, or teachers with me have always told me this before, and I've carried throughout my entire time of understanding mechanisms, because all mechanisms follow this understanding, right? That what you write down, what the name of the mechanism is what's physically happening. Like the name of the mechanism is self-explanatory to what the mechanism actually is. So if it's a nucleophilic addition or elimination, it means there's a nucleophile being added and then a group is being eliminated. I've always said that, and it's true for every circumstance when you're talking about when you're talking about mechanisms, right? Some people get confused by this because they think that this reaction here is not a nuclear. This is a nucleophilic substitution reaction, and I'll explain why. Some people, I know it's kind of backtracking, but I know some people kind of ask me this why, but some people think that because this group is being left off, that this is a nucleophilic substitution elimination because of this happening here, and that's not what I'm talking about. When we're talking about this is not a nucleophilic substitution elimination. This is just a nucleophilic substitution, because when we're talking about nucleophilic substitution or any type of mechanism, we're talking about what's happening on the main compound. We're not talking about what's happening on the nucleophile, on the electrophile. We're talking about, I mean, technically yes, this is electrophilic because this is a nucleophile being attracted to it. But generally, we're talking about this as being the main compound that the reactant, in this case the nucleophile, is attacking. We're talking about what the compound that the nucleophile is attacking here, right? So people think that this, so we're not talking. Sorry, we're talking about what the nucleophile is attacking here, right? We're not talking about what's happening on the nucleophile. Here, the nucleophile is attacking and it is substituting with this other nucleophile here, with this chloride group here. And then to maintain stability, a hydrogen that's on the nucleophile, when it forms a little intermediate here, is being lost to just maintain stability, but it's not affecting the main compound here. It's still this is still a methylamine, right? We're not talking about what's changing on the nucleophile. We're talking about what's changing on the original compound that was affected by the nucleophile. So in this case here, if this hydrogen here was being broken, then we could call it a nucleophilic substitution elimination. I could hear your point for that. That would be true. But we're talking about this group here is this bond, this hydrogen NH bond that's been broken comes from the nucleophile side. So we don't call this nucleophilic substitution elimination. It's just nucleophilic. All that's happening in this reaction is the nucleophile being substituted to this compound. This little thing here, although it's relevant to the mechanism, yes, is not the determining part of the mechanism. It doesn't determine the overall effect of the mechanism, right? It's just something that happens to maintain stability. And I've kind of rumbled on about that, but I get some people asking me about that. We're talking about the main compound. Hopefully I've said it enough times now and people understand what I'm talking about here, and I'm not kind of waffling, but that's what we mean by what this is. This is just a nucleophile being substituted. That's it. That's all that's happening in this mechanism. So hence the name nucleophilic substitution. Shout out Dr. Bakari. Anyway, so alright, so this is one thing that can happen from here, right? And so, and we have that, right? Now there's one issue with this method, and I'll go through it here, right? The primary amine that's produced in this nucleophilic, the primary amine that we've produced in this reaction is also nucleophilic because it too has a lone pair of electrons and can react with halogen and alkanes itself to produce a secondary amine. Now, what do I mean by this, right? So, as I said through here, right, that we all agree that this is still a nucleophile, right? So, I said this. We know that this is a nucleophile, right? This can act as a nucleophile. As I've just shown a nucleophilic substitution where this is acting as a nucleophile. But this is also a nucleophile. This still has this lone pair here. And it's the same reason for this being here. This is also a nucleophile. This is also a nucleophile because it can form 4 bonds. Because we know all of these reactions can stop here. Because that's why I said this, the tertiary amine, so primary, secondary, tertiary amine, they can all end up, the maximum position they can get to is here. Because it can still have this dative covalent bond that can form. So as this lone pair here that's here can form a dative covalent bond because of the lone pair. Because of the lone pair that's still here. This is now no longer a nucleophilic. It's no longer nucleophilic anymore. It's already used up all of its electrons, right? I mean, this is considered more to be electrophilic now. It's considered to be more electrophilic now. But up until this point, that's a nucleophile, that's a nucleophile, and that's a nucleophile. Now, the problem with this mechanism here is I said use excess ammonia, right? I said we're using, in this mechanism, to prepare, what we're trying to do in this reaction is that we're trying to convert this chloromethane here into methylamine. We're trying to create this product and this product alone. However, there's nothing stopping this compound. If I was to draw this compound if I was to draw this out here, right? There's nothing stopping this compound here reacting with another chloromethane here. Because we have excess ammonia. We have an excess amount of it. What's to stop this reaction? What's to stop this? If this, say we've done this one reaction here, but another chloromethane from another part of the beaker is right. There's nothing stopping this reaction from happening. Is that right? So this would be sorry, I drew this compound wrong. Prefer writing it like this. Sorry, my bad here. But there's nothing stopping this reaction from happening. So now we have a primary amine. So this is a primary amine. Methylamine is a primary amine. And you can go another round of nucleophilic substitution to create this. should I do the mechanism for you? I'll do a small little mechanism for you, in case you don't know what's going on here. We know this bond is positive here because we have I can write that as CH3 really. That bond's been broken there, and then we form this here, right? So now we now have a secondary amine. But then this, we also know that this is also nucleophilic. We know that this is also nucleophilic, right? So then, okay, so then what's preventing this now, you know, this compound here? What's preventing this from acting as a nucleophile and reacting with another chloromethane, right? And I think you can kind of get what I'm trying to get at here is the point that this is going to do is all the way until it gets to a quaternary amine. Because this is still acting as a nucleophile, and that's one of the problems with doing doing a nucleophilic substitution reaction to prepare an amine, because that will then react. I'm not going to go through the mechanism again. You know this is going to end up as a tertiary amine, right? We now have a tertiary amine, but then this is also a nucleophile. Sorry, forget about this hydrogen here. Sorry, my bad. This is also a nucleophile. This can also then do another round of nucleophile. We're so far away from all. These are all. By the way, these are all waste products, right? They're all impurities. What we wanted to make, the compound we wanted to make was methylamine, and we've now created all these side products now, side products, waste products, impurities. That's what we didn't want a secondary amine, right? We didn't want a secondary amine. We didn't want to make a tertiary amine, and now we've gone to tertiary amine now. And what's stopping this compound here from then going? Sorry. I know this is pretty daft me going through every single example, but this is what's happening in our reaction. This is what's happening in our beak if we did it via nucleophilic substitution. If you just want me to skip to the part where I go to the end and I actually, I'm I don't like doing it like that. If you just want to skip to the part where I go back to explaining it, you feel free to go and do that. But I am gonna go through every single one here really. Why do I keep doing that? Anyways, I need to go to like this. H3C. Cl, that's a terrible C, I know, but right. And then you can see where this is overall gonna go. This is gonna go to here. And now we've put ourselves in this position here. This is not what we wanted to create. Sorry, my handwriting is a bit poor, but this is not what we wanted to get to. And that's the problem with this. You will get some of this, but then you have all of this as well. And that's not what we want. So that's the problem with this mechanism, right? So, and this process can happen again and again. We call it, in general, this is how I call it and how generally you call it. This is a chain reaction. So how you'd answer, they may ask you a question, say, what is the problem with this mechanism, right? And he says, how I would go about it is saying that, so because this process can happen again and again to produce a tertiary amine and a quaternary ammonium ion as shown below. So you can go from halogen primary, secondary, tertiary, and then quaternary, right? And that's not what we want. So how in the exam, they'll ask you, they'll say to you, why would the student prefer to do another reaction that I'll go through as well, rather than reacting the halogen alkane with excess ammonia? And how it actually, right? So this would be this question would be part D to a question where they want you to go through the mechanism, want you to explain all of this, and you say excess ammonia, what's the conditions and all of that. And then once you've done that, they'll come back to you and say, okay, why would the student prefer doing the other reaction, which I'll go through as well, compared to doing this reaction? And the reason it says that when you're reacting ammonia with the halogen alkane, that will lead to numerous rounds of nucleophilic substitution, numerous rounds of nucleophilic substitution that produce primary, secondary, and tertiary, and quaternary ammonium impurities. Primary, secondary, tertiary amines, or quaternary ammonium impurity, which is not what we want in our reaction. And that's it was usually like a 2-mark question that they ever asked that on. So just be aware of that when you're answering questions. But there is another way. There's another solution that you can do. So there is this method, but there is another way, and the other way is by reducing a nitrile, right? So you can form an amine by a reduction of a nitrile in 2 ways. So there's 2 ways of reducing a nitrile. The first method is by using LiAlH4 and dilute acid. So first of all, to actually get to this position here first, I must actually, I should probably, I'll get this here. I'll move this down here. I'll just move it down here. To actually get to this position first, you have your halogen alkane, right? It's a 2-step process. Well, they'll, let's say, bromine, right? No, actually, that wouldn't be the right one here. Was it? No, it would. It would be. Yeah. Methylbromine, or bromomethane. Bromomethane. This would be bromomethane. Sorry. The first thing you'll do is that you'll react. It'll be a nucleophilic substitution reaction, but with a cyanide group. So first of all, they'll tell you to use the first question that they could possibly ask you is, what's the reagent and why would you use that reagent? Or they mostly ask what reagent would you use and under what conditions. I'll go through the conditions first of all, but the conditions are potassium cyanide, and the conditions are hot and ethanolic, and under it would be under hot ethanolic conditions, and it will be done under reflux. Yeah, it's done to completion under reflux. The reason why we use there's 2 reasons why we use potassium cyanide over hydrogen cyanide. Hydrogen cyanide generally can be a gas, and it could be quite irritant. We have to use fume cover, and we still do a potassium cyanide as well. But potassium, the real main reason why we use potassium cyanide. So we're trying to get this cyanide ion here, right? This is the compound we're going to act as the nucleophile for this reaction. We can either use hydrogen cyanide for this reaction or potassium cyanide. We use potassium cyanide because hydrogen cyanide has a stronger attraction to CN, and potassium ion potassium is a much larger atom and has a weaker attraction to CN, to the cyanide group here. So potassium cyanide would more likely and more strongly dissociate CN- ions in solution compared to hydrogen cyanide. So that's why and you can actually, when you do acids and bases, you can actually tell this actually has a higher acid, so a higher Ka value. I'm not going to go through Ka because people haven't done that yet, so I don't want to confuse people. But the idea being that this potassium cyanide here dissociates cyanide ions more easily compared to hydrogen cyanide, so we'd use potassium cyanide for this reaction. Right, I've kind of gone through that part there. So what happens here is just a simple nucleophilic substitution reaction, really. I mean, in case I'm wrong on that, but I'm pretty certain I'm not. Use a better example here. I don't see anything else happening here. Now get to this point here. And this is a triple bond. We're now here, right? So as I said before, it's a 2-step process, and the first step is actually making this intermediate here, and this is just we'd call this ethane nitrile. It has to have an E at the end of it. Ethane nitrile. and all it is just, it's just that the reagents that you use are potassium cyanide, and the conditions are hot, ethanolic, and I believe it's done under reflux as well. And the mechanism is just usually just this simple nucleophilic substitution reaction here. And now the most important part is that it's the actual reduction part. You're breaking these two bonds here, and you're actually having a H and a H here, and a H and a H here. And this actually confirms that there's no this makes sure that there's no other side reaction. This is a much better way of doing it, because you're only producing the primary amine in itself, and there's no other side product or anything like that. It's just you're just breaking these two bonds here, H H H H, and now you have your, in this case, ethane nitrile. So ethylamine. In this case, we're going from ether nitrile to ethylamine. This H here, this little H here, just represents the reducing agent, and in this case, the reducing agent, which is LiAlH4, and we also have dilute acid, and that's a really good method to have. However, there's another problem with this particular reaction. You can use this reaction in your exam. You can, the reaction is the same for both methods I use, but you can, the only problem isn't to do with the mechanism. The mechanism is fine. This first mechanism is the same. And this second mechanism, really, because you don't have to actually show the mechanism, you're just saying the reaction. The only problem is this here, this compound here, LiAlH4. It's not toxic, there's nothing wrong with that. It's just very expensive. LiAlH4 is very expensive, and to use it in an reaction is quite expensive, and we want to reduce costs as much as possible. So nothing is different from this reaction, apart from the fact that we use hydrogen gas instead, and we use a metal catalyst, usually between platinum or nickel. The one I usually say in the exam is nickel. So, and this reaction has to be done under high temperature and pressure. So we call this reaction catalytic hydrogenation, because it's catalytic and it involves the hydrogenation, because it's H2. So it's just involving H2 and a nickel catalyst. But obviously we do this first part here first, the potassium cyanide part, that stays the same. But the second part here just involves us talking about H2. So we add H2, we're using H2 and a nickel catalyst. And this, although it's under high temperature and high pressure, which is expensive in itself, high temperature and pressure, yes, it's much less compared to the cost of using LiAlH4. And but the process in itself is the same. You're just reducing a nitrile. Now, there's another one we need to talk about here, which is preparing aromatic amines. So these are produced by reducing nitrobenzenes, and this is usually a two-step process. So first of all, with this topic here, right? So if we're reducing a nitrobenzene, right? This is pretty much this here. Is this here, right? Now, I want to talk about this carefully here, because usually this will be part of, they'll never just talk about just this here. What they usually do is that they'll have like one of those questions where they say, it'll be like some 5-step question, right? And they want you to go through step 1, which is going actually some sort of reaction before that. And let's say this is step 2 for a reaction, right? Or step 3, okay? The first 2 steps was the nitration reaction, which I've gone through in my previous video. I talked about the reactions of benzene. So actually, you'll have like a standard benzene, and you'll have, they want you to go through the nitration reaction, AlCl3, all of that. I said that part of me talking about the reaction of benzene and the electrophilic substitution and all that, that's in my previous video. If you want to watch that, I'll leave a link in the description to that. But that's what that part is there, actually getting to this point where for the nitration and getting nitrobenzene. And then they'll talk about, okay, they want you to say, explain the procedure for step. It won't be explain the procedure. What they'll actually say is something along the lines of, what are the reactants or the reagents and the conditions for step 3. So let's say this is step 3, and then overall, what's the outline. They may ask you to outline the mechanism. Now, there's no actual mechanism for this part here. All you need to know is just know that to produce an aromatic amine, we're just reducing nitrobenzene. And to reduce nitrobenzene, you need tin and concentrated HCl. They usually represent it as this, SN just the symbol for tin, and they say /HCl. I never like, even though in the mark scheme they leave it like this for some reason. I don't know why. I'm a victim of it. I did it as well, but it's better to say tin and concentrated HCl, and the conditions is under reflux. It's under reflux. But I say just going from there, NO2, NH2, done. And this forms an ionic salt. So to be able, and so that's the first part of this, right? As I said before, this is a two-step process. In terms of this specific aromatic amine part here first, that's a two-step process. But the thing I was talking before about the actual question, maybe I might make a video on me answering questions on this topic here, right? But this will be involved in some sort of multi-step process, and this might be a part D or part C to a whole question, right? But the actual steps involved in this nitrobenzene is a two-step process. This part here, and then this will form an ionic salt. To obtain amine, to actually obtain the amine by itself, we carry out a second step, which is adding sodium hydroxide base. As I said before, you don't actually need to know the mechanism as far as you don't actually need to know the mechanism for this particular example. All you need to know is that this little step here from here to here, this one little step here is it's a two-step process. So involved in this, I don't like saying a two-step process in a one-step process because that makes it kind of confusing. What I'm trying to say is that in this part here, it's a two-step process, and it's we're reducing nitrobenzene with tin and concentrated HCl, and we're doing this under reflux. And once we've done that, if we want to get the amine, we have to carry out the second part, which is adding sodium hydroxide base. Hopefully I wasn't confusing you there, and if it did, I'll happily answer your questions if you did it, if you want to ask me it in the description of the video, and I'll try and reword it again. But that is the way it is. All I was trying to say is that in the exam, they'll probably give an example where you have to have a multi-step process. But anyway, so now we've come to the end of the video. Now we're talking about to summarize everything they've done in this video, the preparation of amines, at least, or preparation of the amines part. We've gone through aromatic amines, so it just involves us reducing a nitrobenzene, as I just said here. And then we'd use tin, concentrated HCl. Oh, I don't like using I said I don't like doing that. Concentrated HCl. And this is done under reflux. And we would then add our sodium hydroxide base. We then have aliphatic amines. And then we have, there's two methods, we said before, there's two methods of reducing preparing aliphatic amines. There's the method that involves us reducing a nitrile. So I kind of want to separate these two out here. Reducing a nitrile. And then if we were to reduce the nitrile, actually that's the second one. You know what, I'll go through, should I go through that one then? I'll go through this one here first, actually. I'll go through the first one we did first. The first one we did first was halogen alkanes. Plus ammonia, plus excess ammonia. Excess ammonia. Right, that's the first one we said. And it's just, all it is just heat. We need heat for that reaction as well. We need to have a high temperature and excess ammonia, or ammonia in excess. And then we said what the problems with that were multi-random substitution. We don't want that. Produces impurities. Don't want that. So we did reducing a nitrile. So when we do reducing a nitrile, we can use LiAlH4 as one of the reducing agents, but we said that's also very expensive. And it can use dilute acid. So LiAlH4 and dilute acid. But we said what's wrong with that. So then we kind of went on to the other one, which is just talking about using H2 and a nickel catalyst. Or it could be platinum. H2 platinum or nickel catalyst. And that's it. Hopefully this video was useful to you. That'll be it.